Okay, in this video, we're going to be talking about two things, arc length and sector area. Okay, so let's look at the situation that we're going to start with, and we will talk about how to find each thing. So it says the owner of a fish hatchery is sectioning off parts of a square pool to keep different kinds of fish. The fish will be kept in a circular area inside the pool, while the remaining sections will contain pumps, filters, machines, etc. Trout will be housed in the area marked off by dotted lines. So the two questions that we are going to answer is how much area will the trout have in the pool? So what's the area of this entire section right here? And then we're also going to figure out arc length, but we'll do that in just a minute, okay? So for sector area, the first thing we need to talk about is what is the formula or what is the equation, okay? So anytime you are trying to find the area of a sector, so I'm trying to find the area of this whole thing. Now, it's not a triangle because it doesn't have three straight sides. It's got the curved side. So our equation that we're going to have for sector area is this. Okay, the first thing that I'm going to need to do is I'm going to need to figure out basically what fraction of my full circle is this part. Okay, so whatever my degrees are, I'm going to always take that out of 360. Okay, so in this case, we'll have 120 and we'll plug that in a minute. Okay, but I need to take that fraction of the circle and I'm going to multiply that by the area of the circle. Again, sector area. So I've got the fraction for the sector. I need to figure out what that is of the whole circle. So degrees over 360, and then ignore that. Degrees over 360, I'm going to multiply that times the area of the circle. So times pi r squared. That's the formula for area of a circle. Okay, so degrees over 360 times pi r squared is going to give us the sector area. All we need to do now is plug in our numbers, okay? So the degrees that I have for the trout, in this case, is 120 over 360 times pi times the radius, which it tells us is 50, squared. Okay, from here, you need to plug that into your calculator, and we're going to round to the nearest hundredths place for this. So let's go ahead and plug that. All right, so when I plug that in my calculator, I get 2,617.99. And then because this is area, it would be feet squared. Okay, so for any time you are trying to find the sector area of any sector, it doesn't matter what the angle is, it doesn't matter what the radius is, we're always going to plug into this equation, degrees over 360 times pi r squared. Okay, now arc length is very similar, but this time it says the owner needs to enclose the area for trout with netting, including the rim of the circle. How many feet of netting will he need? So if I need to find the arc length, so from here to here around my circle, okay, our formula is going to be very similar, slightly different, okay? So the arc length is going to be degrees over 360 still. Again, it's just a fraction or a part of the circle, so degrees over 360 times. Now, arc length is a fraction of the circumference. So instead of multiplying this times the area, like we did for sector area, I'm going to multiply this times the circumference for arc length. So times 2 pi r. Okay, so let's plug in what we've got. We have 120 over 360 times 2 pi times the radius, which again is still 50. So plug that into your calculator. Let's see what we get. All right, so when I plugged it in, I got 104.72 if I'm rounding to the nearest hundredth. And then we are talking in feet here, okay? Now, that if it was just asking for arc length, I'd be done, okay? But it does say that he needs to enclose the entire area, so this whole part. So if you do need to answer a question like this, we know that the arc length from here to here is 104.72. Now these two, the straight sections, those are both radii of my circle. So this one's going to be 50, that one's going to be 50. So I just need to add the 50 plus 50, which would be 100, to get 204.72. And again, it would be feet. Okay, so for my examples, we're either going to find the sector area or the arc length. Okay, so starting with number 1, we are finding the area of sector BAC. Okay, now the angle's out here. Remember, that's the same as the central angle, so it doesn't matter where that shows. All right, for my sector area, the formula is degrees over 360 times pi r squared. So pi times 9 squared. Again, plug that into our calculator from here, and we will round to the nearest hundred. Right, so when I plug that in my calculator, I got 28.27, and our units are millimeters. Okay, same thing for number 2, sector area of UTV, this one right here. The area is degrees out of 360 times pi r squared. Plug it into our calculator. All right, and round it to the nearest hundredth, 94.25 units are inches. Okay, now number 3 is slightly different. So we need to find the area of the shaded region, so this part right here, okay? So as you can see, I've got this sector that's here, and then I've got the triangle right here, all right? So in order to find the area of the shaded region, I need to find the area of the sector, and I need to subtract the area of my triangle. Okay, so we need to find both of those areas and subtract them. All right, so I know that my angle right here in the middle is 90 because I can see the little box for the right angle. Okay, so let's find the area of the sector first. So again, degrees out of 360, so 90 out of 360 times pi r squared, so pi times 8 squared. All right, let's plug that in to the calculator and see what we. So plugging that in, we should get approximately 50.27 for the whole sector. Okay, now you do still need to find the area of the triangle, so we do have a formula for that. Area of a triangle is 1/2 base times height. So 1/2, the base is 8. And the height would also be 8 because those are both radii of my circle. So 1/2 times 8 is going to give me 32. All right, and then all I need to do again for the shaded part is subtract my sector, 50.27 minus 32, and that will give me 18.27 meters. Wow. All of these, I've made a tiny, tiny mistake. All of these are area, so all of my units should be squared here. So there you go, sector area. Okay, now for arc length, again, our formula is very, very similar, but we're multiplying the fraction by the circumference instead of by the area. Okay, so in number 4, if I'm trying to find the length of my arc here from A to B, that would be degrees over 360, so 140 over 360 times 2 times pi times my radius, which is 18. So let's plug that in our calculator, and we get about 43.98. This one is just length, so I just have my regular units. In this case is meters. Okay, same thing for number 5. We're trying to find the length of the arc from L to M. So my angle is 60 out of 360 times 2 times pi times my radius is 3. Let's plug it in. Plugging that all into my calculator, we should get that it is about 3.14, and our units are feet. Okay, now the last one, we are going to be working backwards here. So it says the area of sector ABC is 2 pi, and the measure of angle ABC is 45. So if you really wanted to draw a little picture, you could. Let's see. So let's say this is A, B, C. The area of that is 2 pi, and then the middle angle right here is 45. And we're going to find out what is the radius, okay? So sector area is what we're working with. So let's go ahead and let's plug into our sector area equation. Again, here is my equation. The area equals degrees over 360 times pi r squared. Okay, so it says that my area is 2 pi. So I'm going to plug that in for the big A right there. All right, my degrees is 45 over 360 times pi. I do not know what the radius is, so I'm just going to leave it as r squared. Okay, now the first thing in an equation like this is I'm multiplying everything over here. Technically, I'm multiplying this because it doesn't have a symbol, okay? So if I have pi on both sides of my equations, those can go away. I can cancel out the pi. Basically, I'm dividing both sides by pi, and it's going to go away, okay? So all I'm going to be left with is 2 equals 45 over 360 times the radius squared. Now, what I think is easiest to do next is change your fraction to a decimal, okay? So 45 out of 360 is equal to 0.125 times my radius squared, okay? Now, I need to get the r by itself, so I'm going to divide both sides by 0.125. So that will cancel out, okay? So that's going to give me 16 equals r squared. All right, now the last step that I need to do in order to solve this equation for r is just take the square root of both sides, and I will get that my radius is 4, okay? So we're working backwards, still working with this same equation, but I am plugging in the area, and I'm solving for the radius. So working backwards, just algebra, but just make sure that you are using the correct equation. So it says area of a sector, that's why I use the one with pi r squared.